We're discussing the open-closed principle. So in this part 5, we'll continue further with open-closed principle and wrap up some discussions on the open-closed principle. Open-closed principle is one of my most favorite principles. I can't tell you how many times I apply this over and over and over. So Bertrand Meyer, when he coined this open-closed principle, I think he really hit the nail on its head. It is about really at the core of extensible software design. So if you really want a software module, an entity, a class, a method, a function to be extensible, it should depend on an abstraction rather than on a concrete type. But be very careful in making that decision. We'll talk a little bit more about this. So where are we right now in this presentation? We looked at a little example of a car class where our car class has different types of engine it uses, but it relies on an abstraction of the engine rather than a concrete type of the engine. As you saw, the engine is an abstract class, and so no matter how many different types of engines you add, the car class doesn't have to actually change. So that is definitely a good news. And we saw that abstraction and polymorphism are really the key in this particular case. Now, having said that, we should really focus on open-closed principle and talk about some of the limits and variations of this principle. Well, the very first thing is that we're talking about a software module being open for extension but closed from modification. Well, if a software module is open for extension but closed from modification, how do we really design for that? And we said we will do that by depending on an abstraction. Don't be in a rush to make that decision, because if blindly we say every time a class or a method has to depend on something, it always has to depend on an abstraction, we would end up creating such a huge number of hierarchies that without really any need for it. So don't provide extensibility in an area where an extensibility is really not needed. If I'm absolutely sure that I would only depend on this specific data format, for example, well, let's say I have a processor that's going to parse comma-separated files. Well, what is it going to parse? It's going to parse comma-separated values. Now, when I say here's a string coming in, there's nothing wrong in assuming that that string is a comma-separated values. I don't need to abstract it out and generalize it, because this processor would never work with anything else than a comma-separated values. Now, depending on a file is unnecessary, because you may not get the value from a file. It could be given as a string. It could come in from other sources. But the fact is, a comma-separated value parser would need a string of comma-separated values. So there is no reason to abstract that any further. So when it comes to closure, the closure is strategic, meaning you cannot create a software where everything is closed all the time and never requires a change. If somebody comes to you and tells you that they can create wonderful software, and once they do, you never have to change that code and it will be ultimately extensible, then there's only two possibilities. Either you're talking to somebody with a very divine power, you bow to him at the time, or you're talking to somebody who is absolutely crazy and speaking no truth at all. But what are the chances? So a software module is not ultimately extensible. It's only extensible for what we actually plan. Now, there will always be a change against which a module is not closed. Let's consider one example for a minute. Let's go back to this example of the car with an engine. Well, I'm going to tell you that in this particular case, I want to extend this. So I am going to say, I'm going to introduce in this case another particular engine, let's say. Well, this is called an energy saver engine. I just introduced an energy saver engine. And I'm going to ask you, can your car that you have there work with an energy saver engine? You can proudly say absolutely it will, as long as an energy saver engine conforms to the abstraction of an engine. So you can quickly come and implement the constructor for it. you can then implement a copy constructor for that as well, and implement the make copy method where you can return, in this case, a new instance of energy saver engine, and voila, you are done. And you can go back and exercise the code, and you can see that the car has been extensible to work with an energy saver engine. But on the other hand, I'm going to ask you, hey, my problem just changed. I want your car to have a dual engine. I want your car to have one main engine but an extra engine. Can you make your car extensible to having two engines excuse me, without having to change the car class? Sorry, we cannot. And therein the point is that the closure is strategic and it cannot be for every single detail. So a class is only closed for what you plan strategically. Now the question is, how do you really get good at planning strategically? Well, I used to work in companies where I am the programmer. I understand software development to a certain reasonable extent, but I'm really not as familiar with the domain. And I would go to the domain experts and I would ask them the question, do we need to support this kind of behavior? Then sometimes they would smile and say, well, Venkat, if we ever have to do that, we'd be violating the law of physics. Well, sorry, I didn't know that. I didn't want to really violate any physics. I'm sorry, I don't want to create that kind of trouble. But the problem is, I got to ask those questions. As a programmer, as a designer, it's my responsibility to ask such questions about extensibility. Sometimes they would look at me and say, oh yeah, that can happen in the domain, but we would never do that in this application. That's not of interest to us at all. Oh, okay, so I won't plan for it. Other times they would say, oh, you know what, great question. We certainly need to think about it. We haven't thought about it until this time, but yeah, I think we should probably design for it, at least have that in mind. I don't know if you're going to support that in the next year or so, but eventually that's quite possible. The application may be supported in that area and we may need these kind of capabilities. Well, in that case and that case alone, I should start providing extensibility. In case where they said I would be violating physics, heck no, I'm not going to support that extensibility because that would never happen. In the middle option where, yes, that's possible, but our application is not going to ever do it, that's the bounded context. I got a bit of a suspicion this probably may happen, but not very likely. So I would have that in my mind, but I wouldn't actively provide extensibility for it. But the last one where they said, oh yes, that's possible, but we're not going to do it right now, but we may come back to it in a couple of years, it's probably worth in that case to have a little bit more discussion and maybe rely on an abstraction and provide extensibility rather than trying to ignore that and tie to something concrete. But in order to make this kind of decision, we need something else. Now, in a typical enterprise or organization, we typically have three kinds of people, right? So three kinds of people. The first kind of people are people with a couple of different things. Let's talk about the domain knowledge, and also let's talk about, so domain knowledge is the first thing. And then we're going to talk about software knowledge, let's say. So the first kind of people that we're going to talk about, these people are the glow-in-the-dark domain experts. Whereas when it comes to software knowledge, they are novices. So expert in the domain and a novice in software. I'm sure you come across a lot of people like that. These people are extremely good in their domain, whatever, financial industry. Talk to them about finance, they can talk to you endlessly about it. They are the people leading, creating algorithms and models in the financial industry. But when it comes to software, they have no clue how to really do anything. The second group of people are the people who are novices in the domain, often people like me. And on the other hand, they are really good. And I'm not saying I'm an expert in that field, but better than definitely the domain knowledge. But these are the people who can get around and do really good software. And there are such people. I am way better than what I could be. I'm talking about people who are real experts who can create nice software. But often they don't understand the domain. Some of them graduate over and start learning about the domain. In fact, the pragmatic programmer says one of the things we should really do as a good software developer is to start learning about the domain. And when we start doing it, we're not going to be a novice anymore. We are going to grow into some relatively knowledgeable. We may not become an expert in the domain. But the third set of people, and I've seen them, I've worked with them, are a very far and few set of people who are expert in the domain and are also experts in the software industry. Now, I worked with personally people who were PhDs in the domain, but they had an undergrad degree in computer science and software development. So these people are really knowledgeable and know it. We'll politely ignore the fourth category here. We won't even talk about them. So if you really consider these three categories of people, I would argue this category of people are the best fit if you really think about it. Because they understand the domain really well, they understand software development really well, so they can think about the ramifications and think about extensibility and start modeling it. But unfortunately, these people are far and few, so what do? Now we can, in reality, combine these two people. This is one of the reasons I always buddy up with somebody else, oftentimes a domain expert or a tester or a business analyst, and say, I'm building this, I'm thinking about extensibility in this area, would we ever have to do this? And they fill in my lack of knowledge in the domain, and I can fill in their lack of knowledge in the software development field. So for us to really come up with a good software design which is extensible, we need to have both the domain knowledge and the software skills. So the designer must decide what kind of change they should really close and plan for. But for that, we need knowledge in the domain and experience developing software. So that combination of the two people working together is extremely critical for us to achieve that kind of capability. But having said that, that open-closed principle is not applicable all the time, but there are several cases where we can see evidences of this. For example, one example of open-closed principle is make all member variables private. Why do we actually say that? Well, the reason is if I go to a class and if I make my year as public, now that the year is public, now what am I going to do? The minute the year is public, well, first of all, you don't want the year to be public because people can come and change it if it's public. Well, you could argue maybe it should be public final int year. Well, now it's okay because you cannot change it, isn't it? Well, in some cases it's okay, but there is one potential problem with it that we have to still deal with. And that is, if you look at this code here, rather than getting the year of the car through the get year, I could simply output in this case, let's say for a minute, I'm going to say car1.year and receive the year value directly. So in this case, of course, when I run this, you can see the year pops up readily. But let's say for a minute, we decide eventually to make a change to the car class. And the change we decide to make is not to store the year, but to actually store the date of manufacturing. Well, what would be the ramification of that? You may first say, aha, but you would be affecting the constructor. Well, not really, because we can grandfather that and we can say if a year is given, then we would simply change this code to say, rather than year equals the year, we could say date of manufacture, let's say manufacture, and then we could say equals new date, or you could use the Jodo time to be current. And then you could specify a 1, and then year is the year that was there. So the year, comma, 1, ignoring completely the date API. I'm not even using the Java date in this case. Any date implementation I'm talking about. Well, then this is not going to be affected. You can write another constructor, and the second constructor that you are writing could be a date, and then this could be manufacturing date, if you will, and you can also provide an engine, if you will, and then an engine. So you can see that existing code that is going to use the current constructor will still work, whereas the new code can start using the new constructor. You can eventually mark this as deprecated and eventually remove it from your API as time goes on. However, notice what's going to happen now here. I'm going to say public final or private final, let's say, and private final date, and this is going to be date of manufacturing. Well, the problem is now, what do I do with the year? Well, I still have to populate the year, especially if it's final, because I got to take the date of manufacturing and put it in the year. But if in the first place, let's say we did not have this as a public field, instead we only had a get year method, let's say for a minute. Now what's going to happen? If I go to this class, I had this as private int year to begin with. Now we introduced a date. I can quietly get rid of the year. Nobody gets affected. And I can still have the public int get year, and the get year method that I have in here, I can now change the implementation of get year. And what I can do here is to say date of manufacturing dot, and whatever function I have to call to get the year, I can return that value from within the get year method. So the point really is, if you publish a public field, whether it's final or not, that public field, just a change to the public field can render all the code it depends on, it, completely have to change. This comes from the procedural days where before object-oriented programming, we had data, and the data structures were wide open, structures all over. And you modify a structure, you can't predict what code in the system will have to change. With the methods, we are able to change the implementation of these methods without having to worry about changing the code that depends on it. I encourage you to go back and review the videos we have on encapsulation and the benefits of encapsulation where we talked about this. That would be very helpful to review that, but that's what we are talking about here. So encapsulation, all classes and code that depend on my class are closed from change to that variable name if I use a proper encapsulation. And furthermore, if this were a public method or rather a field, no class will ever be closed from it, because by changing the implementation, I blow them in the water. So the problem is that we should be very careful about it. So this is why the recommendation of no global variables. And of course, in the case of Java, you can create global static variables, and that's as bad. The second recommendation in this case is runtime type identification is evil and ugly, and we shouldn't use it. We already saw this in our example, if you recollect. We saw how in our example we were using earlier the example where we had the car class, and what did we do in the car? We tried to implement our copy constructor, and the way we tried to implement our copy constructor was by providing, in this case, instance of. So RTTI stands for runtime type identification. Now this is pretty interesting to think about runtime type identification. In the case of C++, RTTI comes in the form of what is called a dynamic cast. So C++ has dynamic cast. In the case of Java, that comes as instance of. In the case of C#, it comes as a function called is. You can ask if it's a type of something. So you have all these functions to detect the type of an object at runtime. It's funny to look back at history. C++ got RTTI in 1999, much after Java was introduced. Bjorn Stroustrup is opposed to RTTI for quite a long time, and he didn't want RTTI dynamic cast in C++ because that would make code really not extensible. And of course, having looked at other classes, other languages supported, eventually C++ got this particular feature. But if you're going to say something like if other.engine and then dot instance of, and then you're going to say, in this case, instance of whatever type it is, what is wrong with this? Every time you introduce a new type of object, you would have to come back and change this code, and we already saw this earlier. Every time I added a new type of engine, we came and modified that code and added if-else statement, nested if-else statement, and that becomes a nightmare for us to deal with, and that is why it is evil. I can't tell you how many times I've come across software systems where programmers have actually done it. Recently I came across a project, very recently, where I open up this file and there is, I'm not kidding, 50 if blocks, not 50 lines, 50 if blocks. If it is an instance of this, if it's an instance of this, and yada, 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 yada. And I asked the developers how often they change it, and they say every time they add a piece of code, they come and change it. Is this the only place you change it? They say, no, we got to go do a search and find out where all we have this comparison, and we got to change it. So go ahead, open close principle violation along with the violation of drive principle. What a nightmare to deal with. So we can prevent these by relying on polymorphism. So rather than going to an object and saying, hey, what type are you? And based on what type you are, I'll do something special. Instead, turn that into a polymorphism. So what you do is you say, if you had a need in your application where you had to do something along these lines, suppose you have a piece of code that says something like, for instance, if the object over here instance is instance of, let's say, type 1, then what are you going to do? You're going to say call method 1, let's say. Then you say if instance over here is instance of, let's say, type 2, then you are calling call method 2, let's say. And if you keep going this way, what you do instead is you replace this particular conditional statement with simply saying instance dot abstract, let's say, method. So the class type 1 will implement abstract method, but it'll do what method 1 is doing. Similarly, type 2 will implement abstract method, but do what method 2 is doing. So your code can be OCP compliant and doesn't have to know what type of object you are dealing with, and instead it simply says, on this object, simply call that method for me, please, so you don't have to really endure that pain anymore in the code. So do not query for the type of object and make decisions, because that will be a violation of the open-closed principle. So having said that, not all of these situations are violations of open-closed principle all the time. So just because, don't paint it with a broad brush and say, oh, you're using instance of, that's a violation of open-closed principle. Oh, you're using public, that's a violation of open-closed principle. Well, it's contextual. Let me give you one example. We saw an example where using an instance of is a bad idea, and it's a violation of open-closed principle. No doubt about it. We cannot argue about that at all. But let's go back and look at a slightly different example. I'm going to go back here and create a car. So we have a car object on our hand. Now I'm going to say car2, let's say car2. And what is car2? Equals new car 2015 comma new energy saver engine. So I created a car2. I'm going to create a car3 here. I'm going to say equals new car. This is going to be 2017 comma new energy saver engine also. Now I want to ask the question, is car1 equals car2? And I'm going to ask the question, is car1 equals car3? Well, but that depends on what the equality of the two is. If I run this code just like this, it says false and false, because the default implementation of equals in the case of Java simply uses identity comparison instead of value-based comparison. But I want to implement this method called equals, so I'm going to add the equals method in this particular case. So how do I go about adding the equals method? Well, I'm going to go back here and provide the equals method. Now, just quickly to note this, I'm not going to do it here, but I note it, that whenever you implement equals, you also have to implement hash code. Noted, I'm not going to do this in this particular exercise, but be aware of that. So given this, what I'm going to do here, and if you're curious why that is, take a look at effective Java. Effective Java tells why you have to override hash code every time you have to implement the equals method. Back to this, we have the equals method, but how do I define the equality? Well, first of all, notice equals accepts an object. And I cannot compare the equality of a car with a dog, for example. The two are absolutely not equal. So what do I do in this case? So what I'm going to do first is, I'm going to say if object is instance of, and in this case car, then I have work to do. Else, what am I going to say here? In this case, I'm going to say return false. Well, if it is an instance of car, I could say then car, this car, let's say, equals, and I could then say, well, actually the other car, so car, other car equals, and car, and I'm going to cast it as an object. Then I could say return, and I could write something like instance of this particular car, so year is equal to, and I'm going to say other car dot year. If you really want to, you can compare the engine as well, but in this case my definition is the two cars are equal if they have the same year. Well, that's the way I define it, right? So we can all define whatever based on our abstraction. Now when I run this code, you can see it says true and false, but on the other hand, if I say output car1 equals blah. So in this case I provide a string, and notice in this case it nicely tells us false, because blah is not an object of car. So when it comes to the comparison, instance of says no, you're not. Now the question is, oh boy, we're using RTTI, that should be a violation of open closed principle, isn't it? Excuse me. So not really. Even though we are using runtime type identification here, this is not going to change even if we were to add other types in the system. Because notice the instance of is checking if the given object we have on our hand is the same type as the class in which we are. So this is a self check, and this is very different from the instance of we used a few minutes ago. In the instance of we used a few minutes ago, we constantly said, are you a piston engine? Are you a turbo engine? So if you add a new type of engine, that code would have to change. In this case, it simply says, are you the same type as me? And that is all it's asking for. The same type of me is not going to change because that's the identity of this particular object as the type of the class, the type of the instances class. So even though we are using RTTI in this particular example, we will not be violating the open-closed principle. So not all uses of RTTI is a violation of open-closed principle. We got to discuss it and say, hey, that seems to be a violation of open-closed principle. So the general rule I follow is, if you have to change a piece of code when something external is changed or introduced, then it's a violation of open-closed principle. But if you don't have to change this code with other things changing outside, and you can make this code extensible, then I think we are good. So, like I said, open-closed principle is one of my most favorite principles. It says a software module must be extensible without having to change it manually. So when I write software, I honestly spend a lot of time not just cranking out code, but thinking through the design ramifications. And when I think about design ramifications, I ask myself, if I'm writing this code, do I have to change this code if I have to bring in a different feature? If the answer is no, I continue to write the code. If the answer is yes, I try to abstract that. In dynamically typed languages, you can abstract a little bit more easily than statically typed languages. So when I code in languages like Ruby or Groovy, I often rely upon more polymorphism and dynamic behavior. When it comes to language like Java and C#, I often rely more on interfaces and then polymorphism. So I change the way I code between these languages, but I'm not taking my eyes off of principles like the open-closed principle. And that is why I love these principles so much. And if you ask me, what do I do in test-driven development? When I'm doing TDD, when I'm writing automated tests, these are the principles I constantly evaluate, constantly keep in mind, and ask myself, if I do this, would I be violating the DRY principle? If I do this, will I be violating the single responsibility principle? If I do this, will I be violating the open-closed principle? And I try to see if I can minimize the impact of these, breaking these or violating these principles. And a net effect of that is the system we develop becomes a lot more easier to extend and easier to maintain, and forces the code to become more modular, forces the code to become more cohesive, forces the code to become less coupled, and those characteristics really pave the way for creating better design. So we looked at one of the most fundamental principles in here, but we got a few more principles to talk about. So in the next presentation, in the next part of this series, I'm going to talk about one of my other favorite principles, which is the Liskov substitution principle. And I'll talk about LSP, Liskov substitution principle. I'll show you some examples of it. We'll take a look at some violations of Liskov substitution principle in multiple different languages, especially I'll show you in Java. And so we can get a better understanding of complying with this in Java, and also making sure we don't violate it, and we can take that and relate to other languages as well. So a lot of fun stuff ahead. So let's continue with this in the next presentation.